okay? If I asked you, here on the graph it says, what's the total distance traveled during the recorded time interval? How far did they actually go? 6 meters, okay? And then what is the displacement? Does it give you a direction? No, so you can't give a displacement. The numerical value for displacement would still be 6 meters, but because you don't know any direction from this, you're not going to be able to tell that. How, tell me, how fast were they going at 2 seconds? I'm wanting to know how fast they're going right there. Well, how do you get the slope of a distance time graph is what? Meters over second. So I'm going to say the easiest way to do this is to, if I'm asking for the time, how fast it is at 2 seconds, put a dot right there. Is it going 1 or more? Okay. Let's say it's going 1.3. Okay? You're going to say 1.3 meters divided by 2 seconds. And when you divide that out, then you'll get the actual velocity at that point. Is that instantaneous or average velocity? Did I ask for it over a time span, or did I ask you for one moment in time? One moment in time is instantaneous. Okay? Let's say we want to know the average speed between 4 seconds and 8 seconds. Okay? Remember how I told you to do the slope? Between 4 and 8, I'm going to say 5.5 minus 2 meters divided by 8 seconds minus 4 seconds. Okay? So 5.5 minus 2 divided by 4. The velocity it's going is going that. Can I leave my answer in that many digits? How many do I need to have? Say it again? Nope. How many did you see in the problem? 2. Okay. So I'm going to have to round that to 8.8 meters per second. And that would be the average velocity of whatever that is in that period of time. Okay? Okay. Let's just keep it running. Okay, so let's look at, let's come over here and look at number 7. Okay, number 7 says the school bus takes 0.530 hours. What is that? What is that numerical value called? If it has hours as a unit. Speak up, people. What's hour measure? Thank you. Okay, and it takes that long to reach the school from your house if the average velocity of the bus is 19 kilometers per hour. To the east, what's the displacement? Okay, how am I going to put that in a formula? What formula am I going to use for average velocity? I gave it to you earlier. Meters over second, so it's going to be what? Distance over time is velocity, right? That's my average velocity. Do you like to put numbers in a problem and then work it, or do you want to rearrange before you put your numbers in there? What's easiest for you? I like to just go ahead and change it like that, but I have a lot of students that have trouble rearranging equations with no numbers in them. Okay? So if you do it this way, and you say 19 kilometers per hour is equal to distance over 0.530 hours, and then work it, you'll multiply this time and these cancel, so this times that. What's going to happen to my units? What unit am I going to end up with? Huh? Kilometers, yeah. Yeah, because my hours cancel, okay? And I end up with 10.07 kilometers. How many numbers should I have in my answer? 3. So where I go 1, 2, 3, and this 7 is going to round that up to 10.1 kilometers. And it's got to have east on it. Why? Because it asks for velocity, not speed. Okay? If it asks for velocity, you have to have a direction. Okay? Displacement has to have a direction. Acceleration has to have a direction. Okay. Now look on the back side of that paper, and let's look at number 12. Number 12 says, what would the acceleration of a turtle that is moving at a constant velocity of 0.25 meters per second to the right? What did I tell you? Acceleration, you have to have what? Huh? Wait a minute, I'm hearing two people. Will? It's velocity over time. But what is acceleration? What must you have to have acceleration? A change in velocity. What did it say right here? Constant. You have no acceleration at all because it's going at a constant velocity. Okay? Okay. Look at number 16. Okay. Number 16 says, a car traveling in a straight line with a velocity of 5 meters per second. So this is going to be my initial velocity, and it's a positive 5 meters per second. After an acceleration, this is my acceleration. The car's velocity is at 8 meters per second. This is my final velocity. Okay. What time interval? Oops, sorry, hon. What time interval is the is it going to take for this? We want to know the change in time. Okay. Yes. 8 with a decimal. Okay. So what's my initial time? From where you start accelerating, which is 0. My final time is what we're looking for, okay? So if acceleration is this, what did I tell you it was? VF minus VI over TF minus TI. Okay? We're going to say 8 meters per second minus 5 meters per second. You have a 0 here, so we're solving for time. And its acceleration was what? That's what its acceleration was. How are you going to solve that problem to get time? .75 is here on this side. And you're looking for that. You're going to say 8 minus 5 first, and you're going to get 3 meters per second. Then what do? How do I get time on the left side? Multiply. So I'm going to have time over here. How do I get the acceleration on the right? Because it's by itself, you're just going to divide. Okay, now look. We're looking for time. My meters are going to cancel, and all but one of my times will cancel. And I'm going to say 3 divided by 0.75, and I'm going to get 4 seconds. How many places should I have? 2. That's my answer. Now, understand that that 0 is significant because it's after a non-zero digit. Okay? It's not before the decimal, just to place the decimal. It's behind an, and this, everybody complains my S looks like a 5. That's a second, okay? Now this is simple math, y'all. Just simple math. Okay? And we just keep going and going and going and do more and more math.